All right, guys. In this video, I just want to show you how to apply the Pythagorean theorem to three-dimensional shapes. So let's recall the Pythagorean theorem is a squared plus b squared equals c squared. Okay. And we know that c squared has to be the hypotenuse of the triangle, or where c is the hypotenuse. What I want us to do now is consider a three-dimensional shape, because hidden inside that three-dimensional shape there are triangles. Okay, so what I'm going to do now is draw a rectangle, and I'd love for you to draw that rectangle with me. The long base of the rectangle will be 3 inches, and we'll make its height 2 inches, as you're going to construct this with a ruler and a pencil. Okay, so there's a 2-inch base. We're not really worried about those measurements in terms of our calculations, but for drawing purposes, you can make this length right here 1 inch. That dotted length is 1 inch. And then this dotted length will be 2 inches back here. Right, and then this connector right here will be 1 inch. You really want to make an effort to make these parallel, this dotted length over here and this solid line here. So now let's draw this going up right here and right here. Well, I don't want to draw that line. I just want to draw the shape. Okay, so this needs to be 2 inches. And just do your best to make the lines straight so that it looks like a 3D shape. Now this line's hard to draw because you want it to be parallel to the one beneath it. You kind of get the idea. Okay, so we're going to go ahead and make that a solid line. And then this one is also 2 inches. Okay, and then we have this vertical here. And connect this guy right here. We're not labeling, don't label these in terms of inches. We're gonna label it in terms of letters. So we're gonna call this point A, and we'll call point B right here, point C right here, point D is going to be back here. Okay, but hold off on drawing that vertical line right there for a second. Point E is going to be right here. And point F is going to be here. G is here. And H is this point up here in the corner, right there. Now this guy right here, I'm going to draw in red. And I'm going to make that in red for a reason. here's the question I have. What is distance BH? Okay, that's the distance we want to find, and we're only going to find it with the letters right now. So let me just identify specifically what I'm talking about. BH is this diagonal that goes from B to H. That diagonal right there. That's the distance I want to know. So how would you find that distance? Well, you have to kind of come about it in a circumspect way. And here's how I want you to think about that, okay? Notice that if we connect B to D, we will have formed a right triangle. Okay, here's the right triangle right here. So there's a right triangle kind of in the space inside the box. Let me see if I can highlight that for you. So this is the right triangle I'm talking about. Okay, and so the question is, how do we find this distance right here? Okay, I want to know this distance right here. That's distance BH. Well, here's an idea. What we need in order to find that hypotenuse length right there is we would need the length of BD and the length of DH, and then we could find it using the Pythagorean theorem. Okay? So, what we would use to build that is we would use this bottom portion down here, because this is also a right triangle down here. Let me show you what I mean. This is a right angle right here. Now I'm looking down into the box. Let me get my highlighter going on that. This is the right triangle I'm talking about. Okay. You see that? You didn't even know that right triangle existed. Or maybe you did. Okay. So, keep this in mind. There are multiple right triangles in a box like this. All right? So that's actually a right triangle. It just doesn't look like it. So you would have to find whatever, you would have to look at what you were given. Right? It would all depend on what you were given, what you needed to compute. But I just want to give you some insight. You can actually kind of work your way to this triangle in pink if you know information about the triangle in green. All right? It's all going to be applications of the Pythagorean theorem. So let's get some numbers going and actually compute something, right? Let's move down here. We're going to draw another one of these shapes. And now that we've got the foundation to think about it, we might have some better luck finding all the missing lengths. So here's a shape. Okay, that needs to be longer. That. So let's draw a rectangle. And we'll draw another rectangle of the same dimensions. So for me, that's 3.5 inches on the long side and 2 inches on the width. But again, we're not worried about that. I'm just telling you, like in physical space, that's what I'm drawing, so you can kind of mimic it. Okay. So then there's some distance here. Right. You got to take your time drawing these so you kind of understand how they're put together. Okay. Okay, so we have a box. And let's label that box A, B, C, D, and then M, L, O, and N. Okay, so now here are the questions we need to answer. Okay, so here are our questions. If AB equals 6 inches, BC equals 3 inches, and BM equals 4 inches. Find the following. OD, that's going to be 1. 2, we want to find CD. 3, LO. 4, DB. 5, BN. 6, AM. 7, OB. And 8, LC. Okay, so these are the units that we want to find. And I'm going to copy this before we solve it so we can keep a fresh copy available if we want to look at a fresh drawing. Okay, so we're going to show our work on this drawing here. So let's label what we know. We know that AB is 6 inches. Let's label what we know in green. This is 6 inches. And BC is 3 inches. BM is 4 inches. That's this height. Okay. And that's all we know. So what do they want to know? OD? Okay, well that's easy. OD is going to be equal to BM. So OD is 4 inches. That was easy. CD is going to be equal to BA, right? Those lines are parallel. So that's going to be 6 inches. LO is going to be equal to CB. So LO is 3 inches. DB, we're going to need to find that. This is exciting. Finally, something cool. All right. Let's do this one in kind of like a salmon pink color. So here's one length we want to know. That's going to be a fun length. DB. Let's see if there's any other easy ones that we can find. BN, B to N. Wow, okay. So B to N, that's going to be that diagonal there. We're going to have to work on that. AM, A to M is going to be this diagonal here. Oh, I'm glad I made a copy so I can copy this over and over again. AM is going to be this distance here, and OB, O to B, wow, that's that big diagonal there. Very interesting on that big diagonal there. And then LC is going to be this cross diagonal here. Well, I bet you that'll be equal to OB. Okay, so I bet LC is equal to OB, but I'm not sure. I'm not sure. So let's start working on this. That is really a cool one right there. So you know what I think I'm going to do? I think I'm going to work on it in pieces. Let's do it this way. In order to find distance dB, we need to understand that distance dA is also 3 inches. How am I going to label that? Label it in this pink color, I guess. So we already know that this distance here is 3 inches. Because that's the same distance as CB, or yeah, BC, and we were given that information. So this is 3 inches. Well, now, remember what I told you from before. This is a right angle, okay? So we can figure out this triangle down here. Let's take a look. See, we have all the information to figure out this triangle down here. Okay, so we can figure out distance dB by using the Pythagorean theorem. Oh, this is really cool. So that dB, that's like C. Okay, and we can call dA, we can call that like A, and BA, we can call that like B. So if A squared plus B squared equals C squared, then dA squared, okay, plus BA squared equals dB squared. How about that? Okay, so we can plug in those values. We know dA is 3 inches. Remember? So this is 3 inches squared, right? And BA is 6 inches. So that's 6 squared, right? And that equals dB squared. That's that missing distance. Okay. So this is a straight up application of the Pythagorean theorem. What we can do is take the square root of both sides. So the square root of dB squared, that's just going to be dB. That's the distance that we want. So that's going to be equal to the square root of 3 squared plus 6 squared. Well, what's 3 squared? 3 times 3, that's 9. And what's 6 squared? 6 times 6, that's 36. Well, what's 9 plus 36? Well, that's going to be like 5 times 9 is 45. So what we're doing is we're taking the square root of 45. And that's going to be equal to dB. Okay. Now we should simplify the square root of 45, right? So we've got to simplify square root 45. If you remember how to do that, what you do is you take 45 and you break it down, right? That would be like 5 times 9 or 3 times 15, something. Break that down into 3 times 5. So you've got 2 3s. See this? So we can rewrite the square root of 45 as the square root of 3 squared. That's 3 times 3 times 5. And this can be simplified into the square root of 3 squared times the square root of 5. The square root of 3 squared is 3, so the simplified form is 3 square root 5. So this would be your answer. This is dB right here. Okay? Three square root 5. Inches. You know, and we would want to leave that exact, but if you run the number in your calculator, you can approximate it. .7 inches. That's what that's about. If you're interested. Which makes sense because the hypotenuse would have to be longer than any of the other 3 sides of the triangle. So if it was less than 6 inches, then we messed something up. All right. Oh, I forgot something that I needed to mention about the Pythagorean Theorem. We should say here, where C is the hypotenuse, and where triangle ABC is a right triangle. You really need to put that in your notes to understand. Okay? So let me go back down. That is so cool. So we figured out dB. dB is like 6.7 inches. That's really cool. That's helpful. Now BN is interesting. Let me find a different color to use. How about blue? BN is interesting. Okay, do we know enough information to solve for BN? Absolutely we do. All right, because we know that CN, or NC, is equal to BM, which is 4 inches. All right, so we already know part of this distance. I guess I'll stick with blue over here. We already know this distance, and that's 4 inches. All right, we just copy that over from BM. So BN is going to be the C value in this right triangle here. This guy here. You have to kind of look at it side, like you're looking at it. If you're a guy standing over here, right? You're a guy standing here. You're looking this way at this thing. You're looking at this right triangle face on. So here's what that would look like. Let me shade that in. So here's the right triangle we're working with on this one. See that? Okay. Well, it's fairly simple. All right. So now we have to compute Bn. Okay. Let's do this down here. Okay, this is our work for Bn. Bn is going to be like the C value in the a squared plus b squared equals c squared. So what we'll say is BC is going to be like the a value. So here we'll write this. BC is the a value, and that is equal to 3 inches. All right. And Cn is the b value. Okay. And that's equal to 4 inches. Okay. So the C value, I don't know why this keeps popping up. The C value is Bn. Oh, I see what's happened. It's thinking I'm clicking. Okay, so Bn is the C value. All right, we don't know that. That is one that we really want to know. Okay, so basically, if we show this work out here, if a squared plus b squared equals c squared, then okay, let's write it out. I want to line it up. Then bc squared plus cn squared equals bn squared. All right, well, let's plug in the values that we know. BC is 3, so this would be 3 squared. Okay, and we know Cn is 4, it's going to be 4 squared. And that equals Bn squared, which we don't know. So we just take the square root of both sides. And on the right side, the square root of Bn squared is just Bn. And on the left side, we got to figure out what's inside here. So 3 squared, that's 9. 3 times 3 is 9. Plus 4 squared, that's 16. 4 times 4 is 16. So what is 9 plus 16? That is 25. Now there's some genius out there that's saying, now when we take the square root of a number, don't we get a plus and a minus? Yeah, absolutely. Okay. So let me just show it out. So remember, the square root of the number, square root of 25 is 5, right? That's actually going to be plus or minus 5, okay, equals Bn. But here's the deal. Here's the deal. Negative 5 is extraneous. Because this is distance. And length. So we discard negative distances, or negs. All right, that's just a little sidebar that you need to be aware of. That's why we are only interested in the positive solution to the root. Okay? So now we know Bn is 5. Inches. So what I want you to do on your own is find 6, 7, and 8. I want you to find these. All right. This was a cool lesson. I like this lesson. I've actually learned something here. So we applied the Pythagorean theorem to 3D shapes. This is some cool stuff, guys. So I'm going to make this file available to you. And I'll also make this video available to you. You know, I just want to explain about the length of the video. Here's the deal, all right? If I, as a geometry teacher, okay, if I'm teaching geometry to you, and you are just presented with these shapes already drawn, okay? I just love zooming in and out on this. This is so cool. You know, you can't like do this with physical notes. If I were to just present this to you already drawn, then you wouldn't get the practice of drawing it. And so from my perspective, we need to take the time, however long it really takes, right? We need to take that time to learn how to draw shapes. I can tell you right now, it was very difficult to draw these shapes on this tablet. But I still think that it was worth taking the time to draw the shapes because you need to practice drawing. Figure if we were to just give you these shapes, you could say, well, we could have practiced the central skill more. And yet I would say, but that throws away the fun part of drawing in geometry. So that's why I went ahead and did it slowly. And here's the other thing, guys. Some of you are saying, can you please like go twice as fast? There's some other people who are saying, can you please slow down to half your current speed? And then there's folks in the middle who don't care either way. For this is the perfect speed. So like this is the Goldilocks speed. I don't know how fast to teach something. This is how fast I'm calculating the problem, and I'm a slow learner. So if I'm taking too long for you, fine, you know, then you're done already. But if this was too fast for you, hit me up, okay? I'm going to tell you how to contact me. If you need to contact me for help with your homework, you can obviously just comment on the YouTube video. So leave a comment. Email me. and that's CMMORELLI at westwoodisd.net. Or send me a remind. You could also just come see me, right? In this modern world, we forget that you could just come by during office hours and ask for help. Okay, so make sure you get help if you need it. Well, that's all I've got for you on this video. I feel like that was probably a long time. I have no idea how long it was. Let me check OBS. 41 minutes. Perfect. So that's the perfect length of a lesson. So we'll just stop there, guys, and we'll call it a day. Good job. All right. Good work. Thanks for your attention.